Again, my name is Sanji. There we go. I'm with Optum. You actually just heard from my colleague, Tamara, who works at United Healthcare. Optum's less well known, but we are an extremely large part of United Health Group, almost equal in size to UHC these days. Unlike our sister company, United Healthcare, that takes health insurance risk, Optum has a diversified range of products and services to serve the healthcare ecosystem, for lack of a better term, industry, supporting state governments, federal governments, payers, providers. We employ more primary care physicians than anyone in the US today, all of which is in service of ensuring better outcomes and trying to work toward the quadruple aim. What that means is that we have lots of diversified businesses and lots of interesting business problems where things like artificial intelligence and machine learning can be applied. It also gets very complicated, and we have to be very thoughtful about how we implement those solutions, but it is a vast range of use cases that we could tap into. So I want to talk today a little bit about analytics in healthcare. Not to say that AI/ML is the only place where analytics in healthcare can happen, but we have a rich history in healthcare of using data to understand the performance of our health system and the outcomes being achieved by patients. Descriptive analytics can tell us how well we're doing for patients. As we rely on more value-based care reimbursement models, things like how often someone gets readmitted after being seen in a hospital, and the readmission rate for those patients becomes incredibly important. And counting all that up accurately and consistently is incredibly challenging, but incredibly important. We could go a little further in this retrospective analysis and try to figure out what happened. Like, are we seeing more readmission maybe from, not to pick on anyone, like a cardiac care unit, or more readmission after a certain type of procedure? There again, we can sort of address what's happening, but in the retrospective. Predictive analytics brings us now to a level where, hey, we are seeing patients in multiple settings, but we can actually guess and score their risk of something, happening, something that we would normally think is not positive. I'll stick with the readmissions example. Like, we can now know how likely someone is going to be readmitted based on the severity of their conditions, maybe any number of features. Especially since we're machine learning guys, we don't always think about the features as much as what is the scoring and risk. But just knowing someone is at risk for readmission may not be able to help us get in front of that, may not be able to say, hey, what can we do to reduce that readmission risk? And that's when we get to prescriptive. Can we change the level of care they get after they leave the hospital? Should they be going to a skilled nursing facility? Or will they be sufficient to go home? That's when we get to really getting in front of some of these quality and performance metrics and actually being able to help people at discharge planning make the best decisions for patients. So we survey our customers all the time, and like I said, we have an enormous number of customers across all segments of the healthcare ecosystem. And almost without a doubt, everyone recognizes that AI can have a significant impact in improving healthcare outcomes and operations. I think empirically everyone believes that. I know my point of view is that what we have with machine learning and artificial intelligence is the ability for us to process so many more features. When you think about the complexity of your life and your health, it's impossible to really say, hey, just because I have a certain ICD-10 code, my risk is going to be X. We know there's a richness in the information we capture about your health, the notes that your physicians might share or other clinical staff. There's just so much information for us to understand. And so I think leaders recognize that there could be a sea change now. But I think that's very specifically because the amount and volume of information we now have in healthcare. So the opportunities are, I wouldn't say basic or well understood, but there's some really, sort of low-hanging fruit that we could start thinking about more. In order to support new reimbursement models in healthcare, like value-based care, we need more complete clinical documentation. Sometimes we need to make sure we're coding things correctly. In a fee-for-service model, we might need to make sure that we're paying for exactly what the patient needed and nothing more, nothing less to help bend that cost curve. And oftentimes, we have mechanisms in the industry to require authorization for medical necessity needs. And can we make that more seamless and transparent and friction-free for the patients and the providers that rely on those processes? As we think about care itself, can we get better at diagnosing and treating folks? Can we understand populations better and understand what we should be focused on? And then there's just overall experiences that we can improve for patients and providers who might engage with us. Call centers a little dated, but whether it's chat or email, can we have more meaningful dialogue? Can we get ahead of that care coordination and understand what are the things someone would need when they leave a hospital, and can we proactively get those resources to them? I talked about level of care upon discharge, but there's so many other facets that we're just starting to explore, like, is there transportation needs that we need to fulfill? Is there medical equipment that needs to be pre-positioned to make a seamless transition from an inpatient setting to a home or other non-inpatient setting? So there's, enormous opportunities, sometimes overwhelming from my standpoint, but it's also extremely exciting. So with all this out there, we've struggled sometimes to figure out what is the most important way to make decisions. I think you heard from, at least I heard from Lisa and from Tamara, identifying and understanding the use cases that you might use to explore building software that uses machine learning and artificial intelligence is incredibly important to understand the value and align business stakeholders. For us, it's no different. And we came up with some ideas on what were some basic criteria that would help us decide what to work on. Every company is going to be different. Every health system is going to be different. And so your answers may vary, but the basics are you start with business value. Is there an opportunity to do something that can have a benefit to patients, to providers, to create some value? We then ask ourselves, how much data do we have? I will say, working in healthcare for about 8 years now, in theory, we think we have a lot of data, but you have to really ask yourself, is it accessible to me in a way that I can build a continuously improving machine learning or artificial intelligence software system? Sometimes our legacy systems aren't designed for that. They are timely or time-consuming to extract the right data and the right information that make it almost impossible to provide near real-time or even overnight or near batch insights because we can't get the data out. We also have to ask ourselves about labels, and this is something that's evolving for us. When we first deployed our first machine learning models in 2018, we relied on the existing decisions that people had made in the transactions of healthcare, like how do you code something, or did we approve this expense or procedure? That answer key we call labels. And oftentimes when we first started down this journey, we relied on the labels that were being generated by the business today, the decisions that everyone's making today. Today, we're realizing in 2022 that we're hitting almost like a theoretical or actual limit in how well our models can perform, because the reality is those decisions can be variable. And so now we're going back and looking at, hey, how well labeled is the data? Do we need the best radiologists to look at these medical images and give them their opinion rather than us looking at all the decision made across our company. And so that's a pretty exciting space for us and something we're trying to get better at. And then finally, we absolutely need to consider the regulatory and risk management aspect of this. How explainable are our recommendations? What is the impact? We've tended, in my team, to focus on more the administrative aspects of healthcare, things like risk adjustment, things like payment integrity, that don't really directly impact clinical decision making, simply because we didn't feel confident that we had every tool available to us to explain what those recommendations look like. Now today, I think that's going to change. I think in the next 10 years, you're going to see clinicians and patients recognize that there's value in getting at least assisted or augmented support for making clinical decisions by synthesizing all the data we have. But we're just starting that journey. The other thing we found is, it is challenging to build the kind of talent and bench that you might need to build a software product to change your business in healthcare. Oftentimes we see teams, 3, 4, 5 data scientists who can accelerate a lot of their insight, but to create a continuously operating system, they need better building blocks. And so some of the things we're thinking about now is how do we give people better building blocks so when a smaller team wants to solve a business problem with AI, we can give them faster building blocks to solve that. Like it could be a large language model trained on clinical data, or it could be a representation of ICD-10 codes, things that they don't have to solve but are specific and critical for many use cases in healthcare. And as you think about building your team, the one aspect of this that I think we found a lot of value around is this middle section, the translator. This bridge, this person, sometimes we call him a product manager, sometimes we call him an AI translator, has been incredibly valuable to us to understand all facets of the use case you're trying to solve, understand the possibilities of the data science methods that we could apply, understand the technical architecture where data often lives, and really understand how to present that back to users. And so it's one of these glue roles that, a lot of people, when I talk to them, they I don't want to overgeneralize, but they'll rush to say, hey, I need to hire a bunch of PhDs from a program down the street because I need to build my data science team. And you do, but these translators are incredibly important to help bridge the methods and approaches to the business value. So one of the first software products we created that used machine learning was something that we created to help accelerate the evaluation of medical charts. There's a bit of a, not arcane, but a very specific requirement in some healthcare settings. Hospitals at times can be required by payers or CMS to provide a third-party evaluation of a medical chart. Like if someone was admitted under some set of conditions and it wasn't terribly acute, oftentimes payers will look for a second opinion, say, could this person have been admitted under observation versus an inpatient admission? And this business that we had was operating very well for the longest time. We had hundreds of clinicians who were at the ready to read charts for our customers and decide if they were warranted to support an inpatient admission. But things started falling apart a little because as everyone wanted to control costs, fewer charts were being sent to those doctors. Oftentimes when you send a chart to a doctor, it's very expensive to have them read and review it. And so to avoid some of that expense, folks may not send it. Worse, in some cases in the hospital, we were asking clinicians or nurses to try to make that decision. Hey, do I need to send the chart for a third-party review when we want them focused on your care in that setting? And so what we did was we trained a deep learning model to read all the charts at a hospital system. And we trained it on the previous decisions our team had made on supporting an inpatient admission. And now, by reviewing every chart, we not only get the charts to the clinicians that are really worthy of a third-party review, but we've eliminated the need for anyone to be on a floor and decide, well, I got to read this chart again and decide if it needs a third-party review. And we've given people the configuration to decide what those thresholds should be based on what they want to accomplish at their health system. And that is a great example, I think, of where we've created software with machine learning, where we've taken a burden off of a clinician, because, obviously they don't make that decision. More importantly, like with software, we could have never contemplated reading every chart at a hospital system. But since this is a machine learning process, all things relatively speaking, it's only incremental compute and data processing to make that possible. So when you embark on your process to build and train a machine learning model, most of the time you're probably going to follow an experimentation path. What do I mean by that? Like, if we wrote a software like, maybe a software to sell, widgets on the internet, I know exactly what I wanted to do. I wanted to list it. I want a shopping cart. I want all that stuff. With the machine learning model, we're essentially asking the computational system to learn from the data. But how we architect that learning, how we structure that learning, can vary. And so we almost take the scientific method and actually experiment on different architectures and architecture types. Now, when we first did this model in 2018, the tools were limited, where we basically constructed a plan with our data scientists to test different approaches. And back then, there were language models like fast text, there were long and short-term memory architectures. Today, what's great is that a lot of that can be automated to some extent. We can tell platforms from Google, Microsoft, and others, hey, test all these experiments at once and tell me which one works. So that's been an incredible improvement on our ability to train models, but the fundamentals haven't really changed. It's still very much experiment-driven. And so this is where you might you might get bludgeoned by your data scientists on how to think about whether or not your model is performing well. And what we've found is typically folks, there's a little typo there. The one on the left is the receiver operator curve. That's typically our sort of standard for understanding whether or not a machine learning model is working, sort of is better than a coin flip. Now, if there are any data scientists in here, they'll tell me that's not really true, but it's a good way to think about it. But this is something that we all need to learn a little bit more about, because yes, I could be really good at guessing with my machine learning model and being right a lot of the time. But if I'm wrong too much, what is the impact? What is the cost? What is the downside? What is the wasted resource? And so by understanding deeply what we wanted to do in these chart reviews, we knew that the hospital system didn't want to miss any chart that would be a justified inpatient stay. And so we actually tuned this model to work better with precision and recall, where you might read a few more charts, but we're not going to be missing as many. And these are the trade-offs. Even if you have a highly skilled set of data scientists, your translator or yourselves will have to understand those trade-offs. We all have to get better at this in order to successfully use these new methods like machine learning. We also face the black box problem, like how is this working? It's a bunch of vectors passed to a network of equations. it's all numbers, so it's almost like impossible to understand what might be happening in that model. And so trust becomes an incredibly important part of how we try to solve use cases. We created something, we used a model with something called intention weights that sort of ride along our core model to help us identify not what's driving the answer, but what's getting activated in that network of equations. We initially did it for quality assurance purposes, to just QA our models. But later we found it to be an incredibly valuable feature that we could show users to be confident that the chart they're reading is a complex case. And so here you could see, like, oftentimes in clinical text in a medical chart, we can highlight what we think is driving that acute level of care that requires an inpatient stay. And this went from being a QA tool to being a feature in the product. Now that's one technique out of many that we could use to help sort of peel back a little bit the black box problem. But it is one that we spend a lot of time thinking about, so everyone could be confident that the recommendations coming out of the ML system are fair, accurate, unbiased, and correct. We also started to build new tools, really visualizations, to help people understand those trade-offs I described. You know, a data scientist will see this and say, hey, that's a confusion matrix. A confusion matrix can be a very dense methodological way to understand how well your model's working. And so we tried to create some visualizations to give people a better sense of, you know, what happens when I move that line between an actual prediction and observed. How many more do I get wrong if I move it to I guess that'd be the right for you guys. How many would I miss if I move it to the left? Now there's a mathematical optimal point we call the F1 score that we could start with, but we found that customers wanted to understand or have the optionality to move that line, to say, hey, let me start maybe with a little bit lower, knowing that I'm going to miss some, or let's pin it all the way to the right and see what happens. I think, again, that goes back to that question of trust and being able to understand how we're going to use this model on a day-to-day basis. And then finally, now that we're live, it's software working every day, we need to think about not only the first pass through this where we create a bunch of experiments and launch the model, but we have to go back and retrain it. We retrain it because it could get better with more data. We retrain it because maybe something changed in the regulatory requirements on defining an inpatient stay. We need to retrain it to constantly validate that we're not introducing an unexpected or unintended bias in the model. And so that's basically, you know, sort of our arc the first time through, and think of it as rinse and repeat once we have the model in production. And I think with that, I'm a little over time. Again, happy to answer any questions. You know, grab my email, feel free to send me a note, and thanks again for your time and attention.